Newton's first law of motion states that an object at rest remains at rest, or if in motion, remains in motion at a constant velocity unless acted upon by a net external force. In this demonstration, the yoga ball remains at rest with no other force acting upon it. At this moment, the ball doesn't move as nothing pushes it into motion. Then, the force from my foot is the external force that propels the ball into motion. The ball remains in a constant motion while in the air, but is pulled down after another external force, gravity, acts upon it. In this second example of Newton's first law of motion, the basketball remains at rest on the floor with no outside forces working on it other than gravity, keeping it at rest. It is then acted upon by an external force when I pull shot the ball, forcing it into motion. The ball then remains in motion until a later outside force acts upon it.
Newton's second law of motion states that when a net force acts on an object, the object accelerates in the direction of the net force. The acceleration is directly proportional to the net force and inversely proportional to the mass. Thus, force equals mass times acceleration. This demonstration with me bunting a basketball shows a small acceleration of the basketball once a small force, the bunt, is applied to the ball. This causes the ball to accelerate in the same direction that I applied the force to the ball. Ultimately, because the net force applied to the ball was small, the acceleration was of a smaller magnitude as well. Following the bunt, applying a greater swing to the ball applies a greater force to it. This greater net force results in a proportional greater acceleration in the same direction that the force, the swing, was applied. Another example of the second law of motion is demonstrated with a medicine ball and a basketball that are approximately the same size, but the medicine ball is 20 pounds, whereas the basketball isn't even 1 pound. As we can see, a similar force was applied to both of the balls, but because acceleration is indirectly proportional to mass, a greater mass results in a smaller acceleration. The smaller mass, the basketball, had a greater acceleration from the same force that the medicine ball received, allowing the basketball to speed up at a quicker rate than the medicine ball.
Newton's third law of motion states that for every action or force in nature, there is an equal and opposite reaction.
Because to every action there is always an equal opposing reaction, an initial force is called the action force and the following force is called the reaction force. In this first demonstration, as I punched Colin, the force of my hand punching him is the action force, and the force of his stomach back onto my hand is the reaction force, thus stopping my hand, countering the initial force. In other words, Colin's stomach, quote-unquote, punched my hand back, which is why the force of my hand didn't continue through him.
In this demonstration, Mason's face displayed an opposite and equal reaction of the ball hitting him. The initial force of the ball hitting him in the face causes the ball to bounce off at an equal speed instead of taking off his head. Thus, this illustrates an equal and opposite reaction, sending the ball back in the opposite direction I threw it.